Welcome viewers, I'm Mamta. Today we'll be doing chapter 3 of class 11th, which is the basis of human behavior. Let's continue the chapter. We have today the concept of nervous system, particularly the central nervous system. Central, as the name suggests, a very important part of the brain structure of the nervous system, which basically deals with three aspects of the nervous system. First, it talks about the hindbrain. Looking at the diagram, you will be able to identify the hindbrain having three parts in it. First part, which is known as the medulla oblongata. Medulla is basically a very important part. It deals with the major life-sustaining and life-supporting functions. All the vital automatic functions, involuntary internal functions are supported by this very important structure of the brain known as the medulla oblongata. It's a connection between the spinal cord on one end and the midbrain on the another end. This is a very important aspect because it helps the person maintain an automaticity so that people can be involved with their normal cognitive functioning, thinking related functioning, memory, reasoning related functioning, and not just focus on automatic functioning. Think for a minute, if your heartbeat stops, what will happen? You'll suddenly face so much discomfort. You might lose your life. So that is where your focus is ensured on your task that you're doing, and it's something like, if you visualize it like having a button that you switch on or you switch off and your functions will start running, but that is not there. It is basically automatic. That is the difference. It's a machine which is working but on its own, regulated by the medulla. Second part is known as the pons. Now, very interesting part because it is dealing with a connection again. One side we have the medulla and the other side we have the midbrain. So pons has a very important part dealing with the fact, it tries and controls a lot of functions actually. One is dealing with the sleeping mechanism, the dreaming mechanism. Research has shown that pons is associated with. It even controls the respiratory mechanism of people. It also controls the internal mechanisms of the body. So in a way, pons is a part of the brain, hindbrain, which is very important again in controlling various kinds of function, very different kinds of functions actually. Third part is again a very interesting part known as cerebellum. Now, this part, cerebrum as such, is actually a motor part because if we talk about riding a bicycle, driving a bike, it could be dancing. Any motor function, any memory associated with the motor function is controlled by the cerebrum. Now, this part basically deals with a lot of functions of motor coordination. So, if a person is not able to maintain a balance, that's because of this particular part. If a person is not able to have equilibrium in the body, a balance in the body, so let's say while walking, I'm not able to maintain a stiff posture, my brain is not giving me the right message to the hands or to the legs to take a step, the next step, then there is a problem with this motor part of the brain. Next, we have the midbrain. Now, the midbrain basically tries and controls through the reticular activating system, the RAS, which is basically dealing with the arousal and sleep mechanism. So, we fall off to sleep because of this RAS system, reticular activating system, and we are alert when we are doing a particular task. We are aware, we are attentive. That's because of the system known as a RAS. Third part of the nervous system, the central nervous system, is known as this frontal brain. Now, this is the forebrain which comprises of different important parts rather. The forebrain is in fact the most important and the most developed, which makes humans very, very intelligent. Now, for the forebrain, the first and the most important part we have is known as the hypothalamus. Now, hypothalamus is actually a very small part but has a major function. In fact, it can be also called as a small brain in itself. It has so many functions which are so important. First major function, it controls your motivation level. If I don't feel like doing anything, I'm not interested in something, I am not able to maintain my energy for a particular task, there is a problem with the motivation which hypothalamus controls. Hypothalamus also controls major, it's like it controls the pituitary or the master gland. So basically then hypothalamus controls all the hormonal secretions in the body. It regulates that. So think about how important hypothalamus is. It also controls the internal homeostasis, which basically means the body is working in a system of balance, of checks and balances. This system internally is controlled by the hypothalamus. Think about a time if you're not able to sweat. When we are in the AC, sitting in the AC, we are not sweating. So when we move out of the AC, suddenly we start sweating. So that is just to balance out the over sweating, is just to balance out the lack of sweating earlier. That's a body's homeostasis, or the body's balance or equilibrium, which is maintained by the hypothalamus. It also controls the emotional part of our behavior. So basically, whenever we are feeling, let's say, too sleepy, or we are not feeling like getting up, that is again controlled by the hypothalamus. So our basic needs, let's say hunger, thirst, these are also controlled. The basic needs are controlled by the hypothalamus, and also the emotional aspect of our behavior. Next we have is thalamus as a part of the forebrain. If you talk about forebrain, think about the word fore. That means at the front. That means it's so important because it controls our major functioning of our brain. All the higher level mental processes, all the decisions that we take, all the thinking that we do, all the logic that we use, all the reasoning, all the attention that we give to a task, all the interpretation, judgment, perception, solving a problem, all of this is done by the forebrain. So think about how important it is, particularly for the human beings, to regulate their life. So second part that we have for the forebrain is known as a thalamus. Now thalamus is a relay station. It's like a radio station which takes on information from one end and transmits it to the other end. That is the role of the thalamus. So it collects the information from the rest of the body, transmits it to the brain. That's the relay station's work. So whatever information from the stimulus comes on to the spinal cord or to the brain, it decides to which center the information has to be sent. Is it to be sent to the auditory center? Is it to be sent to any other center? What kind of processing is required? What kind of decision is to be taken? That's what thalamus role is. And also it tries to control the autonomic systems of the body. Again, like the pons, the internal mechanisms of the body, the automatic functions is what it controls also. Third aspect of the forebrain is a very important feature known as the limbic system. Now the limbic system works in coordination with the hypothalamus. It has two parts. One part which controls the emotions aspect, which is known as the amygdala. The other part known as the hippocampus, which is controlling the memory part. So all the long-term memory is stored in the hippocampus, whereas all the emotional aspects of the mind is stored in the amygdala. Now it works in coordination with the hypothalamus, and it tries and controls the aspect of all the major functions of the body also. Then we move on to the next part, which is a very, very important part in the brain functioning and the most important part of the forebrain also, known as the cerebrum. Now cerebrum basically means the cerebral hemisphere. Now we have two hemispheres, the right hemisphere on the right side of the body, brain, and we have the left hemisphere in the left side of the brain. Now these two in fact serve two different functions. The right one is meant for all the artistic abilities, the spatial abilities, all the expressive and the creative abilities. So think about people who are left-handers, their right side of the brain is functioning. Left side of the body is functioning and right side of the brain is functioning. It works in opposition. Similarly, most of the people who are right-handers, their left side of the brain is functioning, left cerebral hemisphere is functioning. Now, most of the people, because they are right-handers, they are using the right side of their body and the brain, but the left side of their brain. So such people in fact are very comfortable with everything, but the beauty of it all is when we talk about the left-handers, in fact a lot of times in society people are discouraged to be left-handers, saying that if you eat from a left hand or if you write from a left hand, it doesn't really look good. You don't gel with other people, you don't are in association with the way other people behave. But in fact such tendency should be encouraged, because a left-hander basically means that the right side of the brain is functioning very well, the spatial ability is functioning very well, the creative ability is functioning very well, the artistic ability is functioning very well. And if such children are discouraged from their natural tendency to use the left part of their body, they in fact develop a problem. They might end up being slow learners. They might affect the development of their brain. They might affect their intelligence level. And they are much more intelligent because both the sides of the brain are functioning. Obviously, when we talk about language development, which is there in most of the people who are right-handers, working with the left side of the brain. So left side deals with the language development, right side deals with artistic abilities. So for the left-handers, both the sides are functioning. That's why children should not be discouraged or stopped from using their left side of their body, because it encourages the development of both the sides. In fact, even if you want to develop the left side of your body, you can write with the left hand. Obviously, you will not be able to write perfectly like a left-hander, but that will develop the right side of your brain, which is artistic or creative. You can try that, it really helps. Okay, this aspect of the forebrain, which we call as a cerebral hemisphere, the two hemispheres are joined together by corpus callosum. There's a myelinated sheath, myelinated neurons, which are a part of, it's like a bridge which is bridging the two hemispheres, the right and the left hemisphere. Now we have 4 important lobes in this part. We have one of the most important lobes we call as the frontal lobe. Now frontal lobe basically controls all the cognitive functions, all the higher mental related processes, all the major decision making, all the memory related processes, perception, attention, problem solving, judgment, all the major processes are controlled by frontal lobe. So people who are normally calm and quiet, in fact, because frontal lobe even inhibits the emotional arousal. So such people are very cool-headed, they are very intelligent and wise, they take the right decision. But that doesn't mean that our frontal lobe is not activated. Of course it is activated, but for some people it is much more activated. That was the frontal lobe. Second, we have the temporal lobe. So temporal deals with the auditory functions. We hear out certain things, we formulate those memories, it stays with us. That is what is the function of the temporal lobe, the hearing auditory function. Then we have the parietal lobe, which works with the sensory motor abilities. Now all the sensory motor functioning is being controlled by the parietal lobe. So all the different sense organs, all the different cues that we get. Suppose I am walking, my sense organs are giving the message about, is there danger outside which I need to avoid? Is there a hole which I have to avoid? That is all the function of the parietal lobe. Then we have the last one, which is known as the occipital lobe. That controls the vision function. So in every behavior of yours, we are using all the 4 lobes. Of course, we have to make a decision. Of course, we have to look around with our vision. Of course, we have to use our sense organs. Of course, we have to use our hearing. So 4 lobes are very, very important. Last concept that we have is the spinal cord. Now, spinal cord as such has 2 major functions. One is compiling the information from the rest of the sense organs and then passing it out to the brain. And the second major function is about the reflex action. And that has been there right from the time of evolution for survival. So reflex action protects us in a variety of ways. And it's like an inbuilt mechanism. It's a genetic feature. It is not something that we learn. It's inbuilt. It's an inbuilt inherited mechanism that we carry on over generations. Suppose a small child is touching a hot iron. What will be the ideal response? Immediately we'll pull back the hand. So the information will not even need to travel to the neurons. It will immediately be taken back by the spinal cord. Or if I'm blinking my eye, that's a simple reflex action, so that I'm avoiding any kind of, suppose there's something on my eye and I have to blink. So automatic reaction. There's no thinking happening. There is no message being communicated to the brain. So spinal cord is a very quick action, immediate information transmitted and a result or a reaction, very quick without any thinking, very automatic, very inbuilt. That is about the spinal cord, which majorly has a bundle, a network of neurons, and these neurons are the association neurons which associates different paths, and this aspect has the white matter as compared to the gray matter of the brain. That's about the spinal cord. Let's summarize. We have tried to understand today the major aspect of the central nervous system. We tried to cover the hindbrain having 3 parts. Then we moved on to the midbrain and we moved on to the forebrain in the final phase. Forebrain again having very important parts, and along with the brain in the central nervous system, we understood the spinal cord. That's about it for today. Thank you.